ship floating off the coast of British Columbia dumped 100 tons of iron slurry into the Pacific Ocean. With this massive injection of iron into the water, the crew, led by an eccentric entrepreneur, Russ George, sought to create an algae bloom that would not only capture carbon, but also spur the growth of salmon in nearby coastal fisheries. Fisheries that the Haida Nation hired Russ George to replenish. The result? A surge in salmon population the year after the patch of ocean was fertilized with iron. And for Russ George, a firestorm of scientific and public backlash that illuminated the ethical, political, and ecological consequences of these seemingly silver bullet solutions to climate change and environmental collapse. The Russ Georges of the world continued to champion these magical techno-fixes as the path forward towards stopping climate change. So today, I'm going to unpack the consequences of these silver bullet solutions with two questions. Are silver bullet solutions realistic? And if they aren't, why do we continue to pursue them?
Silver bullet climate innovations run the science fiction sounding spectrum from launching mirrors into space to the holy grail of clean energy, nuclear fusion.
That's my fellow YouTuber Adam Levy, who runs the amazingly informative channel Climate Adam, and also happens to have a PhD in atmospheric physics. As Adam just mentioned, there are a lot of seemingly magical fixes to climate change. But today we're going to narrow in on two specific case studies of these climatic solutions that illuminate how and why we seek out fast fixes for climate change. The first is bioenergy with carbon capture and storage, also known as BECCS. Simply put, this technology transforms organic materials such as paper pulp, crops, or bycut from logging industries into energy via fermentation, combustion, or gasification. There are a range of technologies under the BECCS umbrella, but all seek to capture carbon dioxide released during the energy creation stage and then store that captured CO2 into underground aquifers or dried up oil wells.
Thanks to the bioenergy in BECCS, CO2 is absorbed by the plant fuel as it grows, and when the fuel is burnt, thanks to the carbon capture and storage, the carbon is captured and stored. The appeal is that BECCS technologies take more CO2 out the atmosphere than they put in. And because we've delayed cutting emissions for so long, roughly 90% of IPCC scenarios that see us staying under 2 degrees of warming rely heavily on BECCS. In theory, BECCS sounds like a great plan. After all, you're stopping emissions at source, and the biomass is absorbing carbon dioxide out the atmosphere. In other words, negative emissions.
But in practice, BECCS is not the silver bullet solution that it seems to be. One large obstacle for the large-scale implementation of BECCS simulated in the Intergovernmental Panel on Climate Change's scenarios is land use. According to a briefing from the Grantham Institute, models that use BECCS to remain below 1.5 degrees Celsius could require the equivalent of 25 to 80% of our current cropland in order to grow enough biomass to replace current fossil fuel production. Even if we use just 20% of our current cropland, we would have to use the equivalent of all the land in Australia to satiate BECCS's demand for biomass.
Such huge land requirements would inevitably lead to land use changes. This could potentially lead to deforestation, biodiversity loss, and a loss of carbon sequestered in natural sources like trees.
Granted, this is very much dependent on context. In the short term, countries like the US, which has a comparably mature bioenergy infrastructure, could use existing agricultural and logging waste to fuel this endeavor. But in order to scale up BECCS in the long term in line with the IPCC scenarios, this technology would require a massive amount of land for biomass-specific crops.
The level of BECCS in these simulations would require more than agricultural waste alone. Eventually, farmland would need to be diverted to grow crops specifically for BECCS. This means additional fertilizer use, additional trucks carrying biomass to energy plants, and additional freshwater resources to the tune of 0.72 to 24.4 billion metric tons per year. To put that in perspective, global agriculture currently uses about 8 billion metric tons of water per year, and growing fuel instead of food could cause just as many problems as it solves.
It's important to keep in mind that, like almost all silver bullet solutions, BECCS has yet to be tried at a massive scale. Although we shouldn't write it off completely for its shortcomings, we need to recognize it's easier to implement it in a climate model than it is in reality. There's still a lot we have to study and figure out before we can begin to heavily rely on it. That being said, out of all the silver bullet solutions proposed in the last couple of decades, BECCS is one of the more reasonable and achievable. But there are some that are straight out of a sci-fi movie. With that, we turn to solar radiation management, or SRM. In short, solar radiation management is used to describe a range of methods that seek to reflect sunlight back out of the atmosphere to reduce global temperatures. SRM solutions include reasonable and achievable ideas like reflective paint on roofs, but they also incorporate proposals like the highly imaginative space mirrors that would orbit around the Earth.
And one solution that sits right in the middle of that spectrum is stratospheric aerosol injections. Essentially, this would aim to mimic the cooling effects of a volcano by injecting sulfate aerosols into the upper atmosphere. These tiny molecules would form a reflective blanket around the Earth, artificially cooling the climate.
But does this method actually work?
Yeah, it actually seems like it would, although no one has conducted an experiment to inject aerosols into the upper atmosphere. But researchers can study natural experiments by looking at what happens after big volcanic eruptions. The aerosols from these do indeed cause the Earth's temperature to dip for a couple of years. But even though the manufacture and injection of these aerosols would be relatively cheap, they would come with substantial hidden costs.
He's right. According to one paper on stratospheric aerosols, the cooling effect could cause a global shortage of rainfall, especially in summer monsoon regions, droughts, increased air pollution, acid rain, and the possible depletion of the ozone layer. And sulfate aerosols only stay in the atmosphere for 1 to 3 years, which means that constant injections are needed to maintain the cooling effect. If the method was ever suddenly halted, one study predicts that we would experience rapid temperature and precipitation increases at 5 to 10 times the rate of our current global warming trend.
Considering that our governing bodies can barely agree on emissions targets, it's hard to imagine them agreeing on a responsible way to inject aerosols into the atmosphere, especially considering the costs and the benefits aren't shared equally across the globe.
And alongside all of these issues, stratospheric aerosol injections could be used as an excuse to continue burning fossil fuels and increasing emissions, which might be part of the reason why Silicon Valley thought leaders and billionaires alike find such an appeal in these silver bullet solutions.
The path to success is going to require innovation across every one of these sectors. In my experience, innovation can do magical things.
Bill Gates is right. Innovation is important, but these innovations must be pursued in conjunction with the myriad of solutions already available. We must seriously tackle emissions reductions before we try anything else. Because, as climate blogger and physicist Joe Romm notes, some of these silver bullet solutions are akin to using a dangerous course of chemotherapy and radiation to treat a condition curable through diet and exercise, or in this case, emissions reductions. But reducing emissions could necessitate a transformation away from a society that makes billionaires like Bill Gates rich. This then might be the reason why we cling to silver bullets. The distant hope of an easy answer allows us to continue our present actions. That is especially the case for companies and capitalists who profit off our current emissions catastrophe.
When we bet on miracle solutions like sulfate aerosols, we effectively choose a high-risk but seemingly straightforward to implement solution over a low-risk but transformative one. Emission solutions like renewables can offer decentralized clean energy to billions of people across the world, while free electrified transportation can pull millions of cars off the road.
Yes, these answers might have to fight an uphill political battle to be implemented, but they exist here and now, and bring a whole lot more equity and democracy to the table compared to pouring sulfur gases into the stratosphere. If we do indeed need BECCS to stay under 2 or 1.5 degrees Celsius, it can't be the full picture, only one single piece of the bigger puzzle. The answer to mitigating climate change will never be found in one miracle technology. We have to use the multitude of answers currently in front of us, from electrified trains to decentralized solar to the redistribution of food waste, if we want to mitigate climate change quickly. We can't wait around for new tools to mature to start dealing with climate change. We need to begin drastic economic and social transitions now to create a zero-carbon future, a future that is environmentally ethical and just, where we don't have to dim the sun in order to live. In order to collectively create and build this fossil fuel-free world, we'll need scientists, mathematicians, and engineers. Problem solvers who know the consequences of a world with climate change and are invested in preventing it. Luckily, Brilliant is already teaching this next generation of problem solvers through an amazing selection of online courses that use interactive puzzles to hone critical, mathematical, and scientific thinking skills. And the best part is, you can learn these skills from the comfort of your own home. Brilliant is a course-based website and app that lets you explore the realms of math and science through storytelling, interactive explorations, and daily challenges, which is exactly what you'll get when you dive into their Calculus in a Nutshell course. Using visual and physical intuition to present the major pillars of calculus, Brilliant guides you through the intricacies of calculus, an essential tool for aspiring ecologists and urban planners alike. Ultimately, if you're like me and are curious about how the world works, or just want to build your problem-solving skills, then I'd highly recommend getting Brilliant Premium to learn something new every day. So if you want to start developing your analytical abilities, go to brilliant.org/OCC or click the link in the description and sign up for free. As a bonus, the first 200 people that go to that link will get 20% off their annual premium membership. Hey everyone, Charlie here. If you haven't already, I'd highly recommend heading over to Climate Adam's channel and hitting the subscribe button, and then watching the video we made together all about nuclear fusion. Adam's channel is awesome and brings some much needed levity to the climate change conversation. Anyways, I hope you're doing well, and I will see you in 2 weeks.
Hello and welcome to World Bank Live. I'm Paul Blake. We're continuing to take stock of the coronavirus's impact on all aspects of global development this morning and highlighting the work